So I'm going to go over the three optimization problems from this homework. The optimization problems are the ones at the end of the worksheet here. So I'm going to go over question number 1. It says the sum of two non-negative numbers is 10. What's the minimum sum of their squares? So what we want to do is come up with an equation that minimizes the calculation of two squares. And the two numbers are going to be x. If they add up to 10, the other number must be 10 minus x. Okay, and we want to minimize this calculation. So what we want to do then is we want to differentiate that. Okay, and then solve for whether its derivative is equal to 0. Okay, just cleaning this up a bit. 2x plus 20 minus, oops, I'm going to get, it's going to be minus 20 plus 2x equals 0. So 4x equals 20. X equals 5. Okay, so the first number is 5. The second number must also be 5. So the two numbers are 5 and 5. Those two numbers will minimize the sums of the squares. Okay, and that would definitely be the minimum because that adds up to 50, whereas if I just let x be 0 and 10, the other number be 10, we'd have a sum of squares of 100. So that's question number 1. Question number 2 is, it says the perimeter of an isosceles triangle is 36 centimeters. Okay, so I've got an isosceles triangle here. I'm going to call that x and x. That would make this length down here 36 minus 2x. Okay, and I want to find out where the area is a maximum. To maximize the area, I need to multiply length times width times height. So that length here, which I already have, and the height. Okay, so I need an expression for that height. Well, that height is going to be generated by using this right triangle, because I know this length here in terms of x, I know this length here in terms of x. So the height then can be calculated this way. The height is equal to the square root of half of 36 minus 2x, which is 18 minus x squared, minus, it's going to be the long side, so x squared minus 18 minus x squared. Simplify that a bit. That's going to be minus x squared minus 36x plus 324. Okay, so that x squareds cancel out, so I'm going to end up with square root of 36x minus 324. Factor out the common factor, perfect square, and I get a little bit simpler looking expression. Okay, so there's my height. I have my base, so I got my calculation for my area. So the area of that triangle is going to be the base, which is 36 minus 2x, times the height, which is 6 root x minus 9. Okay, I'm going to just simplify this expression a little bit. And once I simplify it, I can just go ahead and differentiate that. So that looks like it's going to be 6. The 2's cancel out in here, so 18 minus x square root x minus 9. Okay, so this is going to be differentiated using product rule. The derivative is going to look like this. 6 times negative 1 square root x minus 9 plus, it's going to be 18 minus x times 1 over 2 root x minus 9. Okay, so I just want to combine that together, and to combine that together I need a common denominator, so I'm just going to use a common denominator of 2 root x minus 9, which ends up conveniently combining with that x minus 9, so I get negative 2 x minus 9. Okay, so that over that common denominator of 2 root x minus 9, and then I get plus 18 minus x. Okay, simplifying that numerator, and I want to solve for that numerator. I'm going to end up with negative 2x plus 18 is 36. Negative 2x minus x is 3x. And that's all over 2 root x minus 9. Solving that equation equal to 0, I get 36 equals 3x, x equals 12. Okay, so if I want to maximize the area of this rectangle or triangle, that's going to be 12, 12, and this bottom length would also be 12. So the most kind of symmetrical shape will give you the maximum area for that perimeter, which makes sense because the most symmetrical shapes will give you the maximize areas for us.